Hello, everybody. I hope you are well and safe and able to work in your classes today. I'm going to talk to you a bit about Chapter 10. Chapter 10 is interesting because, for lots of reasons, it's inductive reasoning. So we've shifted from our Venn diagrams and truth tables, I know, and there was much rejoicing, over to inductive. And Dr. Vaughn puts Chapter 10 in with Chapter 8 and 9 because it's these are the basic forms of argument, and so we have three of them in this particular chapter that are all inductive. I taught it that way once, and ever since I have just pulled the deductive reasoning into one unit and then moved the chapter at the end of that's inductive into the end. So um, none of the rest of this is as technical as what we've just been through, and so we're going to pick up our pace quite a bit so we can finish the whole book before the end of the term. So, Chapter 10 is, like I said, induction, inductive reasoning, and we're going to look at three different types. We're going to look at enumerative, we're going to look at analogical analogies, and we're going to look at causal. Please watch your autocorrect for that one. I get about 75% casual. It's not a casual argument, it's a causal argument, but the U on the correct side of the S. I know, silly English teacher stuff, but spelling is important sometimes. Okay, enumerative induction is an inductive argument pattern in which we reason from premises about individual members of a group to conclusions about the whole group. Now, we know from our chapter on fallacies that there are a couple ways this can go south, right? This will go bad. And one of those is that we're not taking into consideration what is called relevant qualities. And it's like when you ask a small child to tell me how your daddy is like this other person. Well, of course they're going to go on, well, they both have brown hair and they're both tall, and things that are important on the surface but don't really get at the inner workings of things, and that's okay for a kid. For us, on the other hand, we have some work to do. So on page 232 there is quite a few definitions, and we're going to look at a few of those, and then we're going to work on some ways that this actually works. Okay, so enumerative induction, of course, we say is an inductive argument pattern in which we reason from premises about individual members of a group to conclusions about the group as a whole. We have what's known as a target population. It's the whole collection of individuals. If I want to know, good luck on this one, if I want to know how the next election is going to go, I am not going to ask all 250 million eligible voters what they're going to do. Okay, although we may end up trying to do that later. We're going to ask a representative sample. Okay, so the target sample in this one is all of the eligible voters. And our sample is the observed members of the target group or population. And so I'm going to look at what 1,000 to 1,500 of those people think. And then we're going to be able to extrapolate what the rest of the country would do. Excuse me. Now, every time you set out to do one of these enumerative induction, which is a survey sample kind of thing, whenever you start out to do that, you have to kind of believe a few things. One, that people are going to tell you the truth, which, as we all know, isn't always the case. But you have to kind of go with that as your, because if you ask somebody if they're lying about who they're going to vote for, there goes your sample security, right? And the relevant property, as far as definitions go, is a characteristic that is of interest or under study in a target group or population. Okay, so we want to know how they're going to vote. And it would take us more than the rest of our lives to ask everybody who you're going to vote for. So we ask people who are demographically, socioeconomically, and what we should also make sure of is, okay, so where do you lie on the spectrum between super conservative and super liberal? Most people are somewhere closer to the middle. So anyway, there are some things that Dr. Vaughn tells us that we really need to know. My crucial sentences. The first one is, we're talking about the difference between deductive and inductive reasoning. Deductive is easy, right? It's yes or no. It's true or false. It fits in the bubble or it doesn't fit in the bubble, right? All those things we just did in the exam. So, and while deductive reasoning gives us definitive answers, he says inductive reasoning, though, gives us most of what we know about the empirical workings of the world, allowing us in science and in ordinary experience to soar reliably from what we know to what we don't. And that is kind of the place of all inductive reasoning, is to say, okay, we know, we need to know 6 things. We absolutely, or maybe not conclusively, we like conclusively though, we know these 5 things are good. It's that 6th one that we have to figure out. Well, if we know these 5 and we're right about these 5, then to figure out what the 6th one would do is usually pretty easy, right? We can go from what we know to what we don't know fairly well because we have the information, we have done the data, we have done the research, okay? And a couple of things that we need to know about these target groups and samples. The target, of course, is the big group, right? The sample is the bullseye, if you want to think about it that way. So the more homogeneous a target group is in traits relevant to the property in question, the smaller the sample can be. The less homogeneous, the larger the sample should be. Now, that's something that we have to be very careful with, right? Homogeneous in this sense means the characteristics that impact the question or the pieces, the relevant property of the target group has to match what we choose for our sample. And we're going to talk about that mess here in a minute too. Okay, so if we're going to survey for some reason only women over 50 who have at least 2 kids and have been married for at least 2 years this time. And okay, so the more of these qualities that we have alike based on what we want to ask them about. Okay, we want to ask them, okay, so how do you budget your money so that you actually can take care of all these folks? Okay, so, and all of our target is women over 60, da-da. Okay, so we have all these folks that we're talking to. And they're all very similar in lots of ways that make our target easy to manage. And so we're looking at just those folks. And so we can say, okay, so I have 50,000 people who fit. I can really look at answers from 10 or 50 and get a good idea of what's going on because they're very homogeneous. Now, if I say, here's one of the problems with our national polls. If I say, oh, Americans, good luck finding homogeneous there. Americans are going to vote this way in the next election. And then I've got to look at demographics because that makes a difference. How old you are, where you are in that kind of spectrum. Socioeconomic, how much money do you make? How do you make your money? That kind of thing. There are so many answers. And so our polling has to be relatively large because otherwise we won't get a clear answer. And sometimes even when we follow all the rules and do the polling the right way, which means, we have to vet how we do our questions, what order we put them in, how we ask them, how many questions, all those kinds of things go together. And then we make our big sample. We have 1,500 people, and we're going to do our thing. And we don't get the right answer at the end. Nobody should be surprised. Now, it's part of that, and we've been kind of on our heels about election polls for a good while now. It's difficult to see how we could make it better without spending years and years doing it, which in an election we don't have. Excuse me. So we have to be careful with that our sample matches our target audience in all the relevant ways, and that we ask the right questions to the right people in the right order. So opinion polls, while they look fun and easy, are really, really difficult and complex. That's most of what this thing is talking about. So an opinion poll, as a sophisticated enumerative induction, must use a sufficiently large and representative sample to ensure that the gathered data accurately reflect what's being measured. Okay, so that makes sense. Now, we get into a couple of different problems, right? And we've seen some fallacies before, where we're looking at how much information we have and what kinds of things we can actually say. Now, obviously, we can say whatever we want. No, if we're following the rules and trying to make an opinion poll work, we're actually going to ask the questions that we want answered, and we're going to get the answers that we want from the folks that we ask, and it's going to show us something about the larger target audience. See how that goes. Okay, so there are a couple ways that an enumerative induction argument can fail to be strong. Excuse me, two ways. One, the sample isn't big enough, right? The sample is too small. Or the sample is not representative of the target group. I think both of those come into play in pretty much anything we do. I was hoping this wasn't going to be an issue today. Allergies. Anyway, so we know from chapters past that one of the things that we do is, as a fallacy, is a hasty generalization. It leads to prejudice, it leads to bias, all those fun things. And hasty generalizations, basically using too small a sample size to draw conclusions from. The people are too complex to make a conclusion based on just a few of its members. It's also gives us, like I said, stereotypes. And if it's a very heterogeneous group, which means they're very different, we flung them into this group and it doesn't quite work because they don't know each other, they're not like each other, and that may be fine, but makes our job harder as pollsters. Okay, a few more definitions. Most of these are on the review notes on page 333 has all of these, just in case. The representative sample is a sample that resembles the target group in all the relevant ways. A biased sample is a sample that does not accurately represent the target group in some way. This one always cracks me up. Okay, so you want to know something medically about women. Okay, so you want to know basically how many women die of cardiovascular events, and then you want to find out what we should do, basically. How do we treat this? But you use a medical experiment, hypothesis testing kind of thing, but they were all men. This is why heart failure, cardiac incidences are the #1 killer of women in America. Why? Because it wasn't until the 1990s, which I know sounds like a long time for you guys, but I was here for that. It wasn't until the 90s that they really started doing research on heart attacks in women. One, in that, so there are certain, I'm going to digress a minute here and then I'll come back. So for men, there are a few things that you can look at as a doc and say, oh, you're at higher risk for a cardiac incident than, say, this person over here. And they get that. It's um, cholesterol and blood pressure and weight. Okay. And so if you have high blood pressure, if you have high cholesterol, if you're overweight or obese, your chances of having a cardiac incident are higher than somebody who is on target for their weight, has lower blood pressure, and their cholesterol is lower. Okay, so they made all these extrapolations about what you should eat and how you should do and medicines and all of that. Okay, so, and it works for men. They tell us it works for everybody, but no. For women, now, if your blood pressure is super high and you are morbidly obese, okay, yes, those things, but in a more extreme measure than for men, those things can increase your possibilities. Cholesterol, on the other hand, not a good indicator. Women have higher HDLs, which is the good cholesterol, and it just doesn't correlate. Regardless of how you kind of spin it out, it just doesn't correlate. The big deal, and this is also true for men, but to a lesser degree, the big deal is how much do you move every day? And it doesn't necessarily have to be the 10,000 steps thing, but are you in a job where you sit mostly? Are you in a job where, it's high pressure, high stress, very little reward, which is a lot of jobs. But anyway, so for women, that research that was done for heart attacks and things doesn't really follow. And so we have a lot of women. And the other thing is, when you're having a heart attack, we know from all those medical shows on TV and actual research that, if you feel like there's an elephant sitting on your chest, if you've got pain radiating from your left side down your left shoulder, and there's another one. Anyway, those are the typical male signs that you're currently having a heart attack. Okay. Most women don't have those symptoms. Okay. A lot of women don't know that they've had a heart attack. Of course, if it's a relatively mild one, until they go to the doc and he's like, what was going on 3 days ago? And so women have more centralized pain. Sometimes it really is mistaken for some sort of gastro issue or heartburn. Some women get blinding headaches and then coughing. That's their only actual sign that they're having troubles. And since we get headaches a lot based on hormonal shifts and all that, we might not always twig to that's what's going on. And women tend to mask pain, given that, period cramps and childbirth and all that is a lot more painful now that they started putting monitors on people. A lot more painful than male docs really realize. So there's a lot of things that go into that. And so back to definitions, sorry. Random sampling is crucial for a good, solid, cogent opinion poll. Random sampling is a sample where every member of the target group has an equal chance of being selected for the sample. Okay, so you have 1,000 people in your target group. You want to take 10 for the sample. Everybody in that target group has an equal chance of being part of the sample. Okay, that's a random sample. Humans aren't very good at randomness. You might say, oh, I love random, or she's random, or he's random. Okay, but when it actually comes to picking things at random, we're just not very good at it. And so it makes it more difficult to do good sampling. Now, we do have computers for that, but since they're based on what we think, sometimes they're not even good at randomizing. Think about this. If you have your music device on shuffle, technically that's not a random setting. We don't have one of those. Randomize. Okay. Because one of the things that our random sampling does that way is it weeds out, you can't play the same song twice. So I have 1,000 songs. I'm not necessarily going to hear all 1,000 of them before I hear the one I want again, because that's just not how that works. But random sampling really would mean I might hear the same song played back to back, or I might hear the same song played, 1, 2, 3, 4, 1, 17, 22, 20, it's like that. So it's kind of interesting to see about our brains don't like randomness. Now, there are a couple kinds of, biased sampling, and that is too small of a sample, but also a self-selecting sample. Any of those things where, okay, so I go to this website on a regular basis and I read their stuff, and one day they ask me for my opinion on something. Okay, great. But that's a self-selecting sample, just like our our course evaluations. You guys are supposed to do course evaluations, and I'll have 20 students in my class and I get 3. Is that a significant sample? No. Can we make any kind of recommendation based on those 3? No. Because usually in a self-selecting sample, you're going to get the folks who are really super yes or really super no. And so all the stuff in the middle kind of gets lost. Okay. So opinion polls, well, we have margin of error, which is, sorry, I'm backing up a little bit. Margin of error is the variation between the values derived from the sample and the true values of the whole target group. Okay. And you're going to see that on any of these polls that we have. It'll say, oh, John Smith has 42% of the vote and Sally Smith has 42% of the vote, but it's a plus or minus 6%. Okay, nobody's winning at the moment. We can't say definitively who's got the higher bit because we have too big of a margin of error. Our confidence level is the probability that the sample will accurately reflect the target group within the margin of error. The bigger the margin of error, okay, the better your confidence is that you're going to get somewhere in there. So if my margin of error is plus or minus 2%, I have to be pretty good at picking my sample, or I have to ask a lot of my target group to do this because my margin for error is only this big. Now, if my margin for error is this big, plus or minus 8%, then I can be pretty confident that, oh yeah, I can get in that 16, 8 plus, 8 minus, I'm good. Yes, we're good. Now, we may still be wrong, but we're good. Okay, opinion polls must follow the rules for strong, cogent, inductive arguments. You have to have a sufficient sample size, sufficiently random samples, reasonable questions, and Dr. Vaughn gives us a bit about surveys in their questions. Okay, so question phrasing, we can lead people to the answer we want. Question ordering, if you ask a negative question before you ask the one you really want to know about, chances are your sample set is going to be off a little bit. Restricted choices, we can only ask certain things, or they can only answer certain ways. You choose one of these, choose all that apply, that kind of stuff. Okay. And then there's the math stuff. Okay. On page 330, he gets into a bit about mean and median and mode. Now, there are a couple of things that you have to know about these. The mean is just the average. Okay. And that's usually what we want to see in a percentage. Okay. So the average voting for this particular issue is, okay, so we have 100 people, and their average for saying yes was 96%. Great. So we're good, right? Because our margin for error is plus or minus 3. Okay. And then we have the median. Okay. And this is kind of a funny, anytime you go looking for a house, you're going to buy a house, you're going to rent a house, whatever, they're going to show you the median house cost in this area. Well, what is median? Middle. Okay, it's not the same as an average. An average is you take all the numbers, you add them all up, you divide by how many numbers you have, that's your average. The median is, okay, so I have 20 things, and my median is whoever's sitting in number 10. Doesn't matter how close to the top, how close to the bottom, whatever, just whoever's sitting in number 10. Now, the mode is even more interesting because we don't use it very much in statistics and all that kind of stuff, but it's there. A mode is the answer that shows up the most. Okay, so if in that house buyers thing you have 20 things and 4 of them are 150,000, that's your mode. Okay, it's not the median, it's not the average, it's the one that shows up the most. And so it's probably the least useful one, aside from giggles, in that opinion poll thing. Okay, I'm going to try to speed up here because you guys are already sitting here for half an hour. You can always pause and come back later. 10.2 is analogical inductions. We have definitions and criteria, and then an argument pattern. And I'm working off of my PowerPoints today, so should have made that one bigger. Definitions and criteria. These start on 338 and go to 343. Okay. So an analogy is a comparison of 2 or more things alike in some respects. A literary analogy, sorry, I gave you up the nose look there. A literary analogy is a comparison that's not an argument, but makes a poignant or poetic likeness. So, Emily Dickinson, my life had stood a loaded gun. It gets better from there, I promise. But that is a comparison. My life, loaded gun. Okay. But it's not an argument. Okay. Analogical induction, which is also called argument by analogy, is used to argue inductively for a conclusion. It reasons this way: because 2 or more things are similar in several respects, they must also be similar in this respect. Okay. That whole looks like a duck, if it quacks like a duck, it's probably a duck. Relevant similarities are those similarities among the things being compared which have direct bearing on the conclusion being argued. So you have to be careful, again, if you're looking at an analogy. So this person is your age, likes the same anime you like, goes to JCC, you're an IT major, so they probably are too. Okay, yes or no? It depends. You might get lucky on that one. Relevant dissimilarities or disanalogies, those ways that things being compared are different, where those differences have direct bearing upon the conclusion. The more disanalogies present, the less likely is the conclusion to be true. Okay. The number of instances compared, basically, how many things are you going to say are the same? Okay. A, B, C, D, F, G, or just A, B, C? Makes a difference. Okay. As long as all of those are relevant. That's a big word for us. Diversity among cases This state of affairs suggests the similarities are not accidental or contrived, but are strongly linked, even in a variety of situations. Okay, so when we're looking at how people are going to behave, and that's always what I would call a crapshoot. Um, you have it's going to land one of 6 different ways. And so you think about how different we are, just the person sitting next to us, but then also how very similar we are. When you start looking at DNA, we're very similar to turtles. We don't look like a turtle, we don't act like a turtle, but a lot of our DNA is the same. So you have to be careful what you're comparing, what you're using to compare, so that you can predict things. Okay. And to that is our analogical argument pattern. Thing A has properties P1, P2, P3, plus this property P4. Thing B has properties P1, P2, and P3. Therefore, thing B probably has property 4. Okay, P4. There are review notes for that on page 322. Ta-da! Okay, causal arguments. I will tell you from a statistical point, causality is really hard to prove. Okay, just because things happen in sequence doesn't mean they happen because of what happened before. So anyway, we're going to look at some things here. Okay, our definitions are on page 347. So a causal claim is a statement about the causes of things. Okay, a causal argument is an inductive argument whose conclusion contains a causal claim. So make sure your conclusions are what you're looking at. Inference. Okay, and we already have this, I think, on our big words. The process of reasoning from a premise or premises to a conclusion based on those premises. Oh no, but it will be. Inference to the best explanation. Da, 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 da. Okay. A form of inductive reasoning in which we reason from the premises about a state of affairs to an explanation for that state of affairs. Okay. So here's our thing. Phenomenon Q. Okay. So this thing happened. And this E explanation provides the best explanation for Q. Therefore, it is probable that E is true. Okay. Again, probabilities, that's a good thing. We're not in definitive, just probable. So we're testing for causes. This is John Stuart Mill's. This is highly summarized, okay? Even in the book, and he says highly summarized. John Stuart Mill was a theologian and philosopher, and he liked things to be in order. I'll just put it that way. Okay. So taken from John Stuart Mill's methodologies, this is the method of agreement. If 2 or more occurrences of a phenomenon have only one relevant factor in common, that factor must be the cause. Okay? You weed out everything else. There's one thing that's different. That must be the cause. Difference. The relevant factor present when a phenomenon occurs and absent when it does not occur must be the cause. So, okay, so my silly thing, if there's chocolate in the house, I'm happy. Okay, so I'm depressed, severely depressed, and my husband asked me, "Did you have chocolate today?" "No, I'm out." Okay, well, when you're out, you're depressed. When you have chocolate, you're happy. So there's your difference. Now, sometimes they work together. It's a both agreement and difference. He says that this is a joint method. Applying both methodologies increases the probability of the conclusion being true. And then correlation is basically as one thing increases, so does this thing we're looking at. And so they kind of run around together. That's correlation. When one varies close in connection to the other, they are probably causally related. Not always, but probably. Okay, and then we have causal confusions, and there are 5 of these that he talks about in the book. And I'm just going to run through them fairly quickly here. Misidentifying relevant factors. Okay, Relevant factors include only those things that could be related to the conclusion. Lack of background knowledge can hinder identifying relevant factors. Okay. Mishandling multiple factors, not having enough relevant factors, and or having too many can muddy the waters. Again, lack of relevant background information can hinder the process. So multiple factors, you have 17 things that could be the cause of something. Well, you weed them out one by one. You don't just say, oh, here's the thing, scattershot, right? Being misled by coincidence. Given the number of daily events, most craziness is bound to happen. Thinking about a friend that you haven't talked to in a few years, and then they call you. It's a coincidence, really, when you think about all the people who think about their friends and somebody gets a phone call. It's like saying, okay, there's an 80% chance of rain today, and all you get is some cloud cover. And you're like, well, they were wrong. No, somebody had rain today, and in 80% of the cases, that was true. You were just in that other 20. Confusing cause with temporal order, sorry. Just because one thing happened before the other doesn't necessarily follow that thing one caused thing two. I like to see the old Dr. Seuss guys. Confusing cause with effect. Which comes first? Which causes the other? It's sometimes hard to figure that out. Think about the perennial question. What came first, the chicken or the egg? Okay, it's a cycle. Our crucial sentence number 4, don't assume that a causal connection exists unless you have a good reason for doing so. Okay, causal is hard. Things don't directly cause another thing very often. So we have to be very, very sure that we're saying, okay, this particular thing caused this. Okay. The last piece, and we talked about this, I think, back in chapter 2. Necessary and sufficient conditions. Since causal processes always occur under specific conditions, it's useful to understand the conditions for the occurrence of an event. Necessary conditions, the sometimes rather long list of conditions needed for a given event to be caused. Okay. Sufficient conditions, the specific combination of events or a single key event that guarantees a given event will be caused. Sometimes a condition can be both. I think a lot of times condition can be both. Okay, our last two crucial sentences. A necessary condition for the occurrence of event is one without which the event cannot occur. If you pull that out, nothing happens. I always think about combustible fuel, right? So in your car, unless you have an electric or a hybrid, and hybrids still have one, the internal combustion engine. Okay, so you get this little piece, this little bit of gas that goes into the piston, and it gets compressed and it blows up and makes it go. Okay, so if you don't have enough pressure in your piston, your car's not going to go. Okay, now that's kind of the extreme end of your car's not going to go, because this means you need a new engine. A sufficient condition for the occurrence of an event is one that guarantees that the event occurs. So in order for that piston to fly up and actually, create movement, it has to have gas. No gas, no move. We all know about that. Okay, so chapter 10 is long and has 3 parts, and we're going to use all 3 of those parts as we go forward into 11, 12, and 13. So make a good outline, do your thing, and let me know if you have questions. You know how to find me. You have my email.